Hi friends, every time you fill petrol in your vehicle, do you know the long journey it has taken before reaching you? Let's explore how crude oil is transformed into petrol step by step. Now let's understand the first step in petrol refining, crude oil arrival and storage. Crude oil is transported from oil field to the refinery. As you can see here, it mainly comes through large ships called oil tankers. These ships carry huge quantities of crude oil from other countries. Crude oil storage. After arrival, crude oil is stored in large storage tanks before processing. These tanks are specially designed to safely store large volume of oil. What happens in storage? Inside the storage tank, crude oil is temporarily stored. During this time, water and heavy sediments settle down at the bottom. Then samples are taken and tested to check the quality of crude oil. Finally, the stored crude oil is sent to different refinery units whenever required. After crude oil storage, the next step is crude oil filtering process. This step removes unwanted impurities before refining begins. Initial screening. First, crude oil passes through coarse filters. These filters remove large impurities like sand, stone, and rust particles. This is the basic cleaning step. You can see this image. This is a coarse filter. This filter removes sand, stone, and rust particle. Water separation. Crude oil may also contain water, so it's sent to settling tanks or separators. Here the water is separated and removed from the crude oil. This helps improving the quality of crude oil before further processing. Electrostatic desalting. The main cleaning process is electrostatic desalting. In this step, crude oil is mixed with water and heated. Then an electric field is applied. This process removes salt, dirt, and even metal particles from crude oil. See this image. This is electrosalting process. Here electric field is applied in crude oil. The salt is removed from crude oil here itself. Heating process. After removing impurities, the next step in the refinery is heating the crude oil. Crude oil enters furnace. The cleaned crude oil is sent into a furnace, also called a heater, through long metal pipes. You can see this image. This is a metal pipe. This pipe carrying crude oil. This is a heater, burning fuel to generate heat. Inside the furnace, fuel gas is burned to produce very high temperature, around 350 to 400 degrees Celsius. But here is an important point. The flame does not touch the crude oil directly. Instead, heat is transferred through the walls of the pipes carrying the crude oil. So the oil gets heated safely without direct contact with fire. Due to this high temperature, crude oil becomes a mixture of vapor and liquid. Sent to distillation column. This hot mixture goes directly into the distillation column, and this is where the separation of different petroleum products begins. Now comes the most important step in the refinery, the separation process, also called distillation. A distillation column separates crude oil into different products based on their boiling points. Entry of heated crude oil. From the furnace, crude oil enters the column as a hot vapor plus liquid mixture. Temperature is very high at the bottom. You can see this image. This equipment is called column. Temperature gradient. At the bottom of the column, it's very hot. Top of the column, it becomes cooler. This temperature difference helps in separating different products. Vapor rising upwards. Light components which have low boiling points rise upward as vapor. Heavy components which have high boiling points remains at the bottom. Condensation at different levels. Inside the column there are trays. As the vapor rises, it cools down and condenses into liquid at different levels. Each level collects a different petroleum product. Product collection. After separation inside the distillation column, different products are collected at the different heights. Product collected at different heights from top to bottom. See this image. At the top of the column, we get LPG, which is very light gas. Below that, in the upper middle section, we get petrol, also called as gasoline. In the middle section, kerosene is collected. Further down, we get diesel. And at the bottom, heavy oil or residue is collected. So, lighter products are collected at the top and heavier products are at the bottom. Continuous process. This process is continuous inside the column. Vapor keeps rising upward and liquid keeps flowing downward. Because of this continuous movement, separation keeps happening all the time. Why petrol from distillation column cannot be used directly? The petrol obtained from distillation is called straight run petrol and it is not suitable for direct use. You might think that once we pump oil out of the ground and put it through a distillation column, the petrol is ready for your car. But if you put straight run petrol directly into your engine, you would likely ruin it. Here is why we can't use it yet. Please see this animation. If we use straight run petrol in our car, it will damage our engine. There are four main reasons. Low octane number. It burns too quickly, causes engine knocking, damage to engine. Engine needs high octane petrol for smooth running. Poor performance, not stable, less efficient combustion, lower mileage. Less quantity. Distillation gives only limited petrol. Demand is much higher. Impurities present contains sulfur and nitrogen compounds. It produces pollution and engine problems. Petrol from distillation is low quality and impure, so it must be processed further before use. Petrol cracking process. Now let's understand the cracking process, which is very important in refinery. Cracking means breaking heavy oil into lighter and more useful fuels like petrol and LPG. First, heavy oil is taken and heated to a high temperature, around 450 to 550 degrees Celsius. Then this hot oil is mixed with catalyst. A catalyst is a substance that helps speed up the reaction without getting used up. In this process, materials like zeolite are commonly used. Due to high temperature and catalyst action, large hydrocarbon molecules started breaking into small molecules. So big molecules become small molecules, and this produces petrol, LPG, and other light gases. This process is very important because it increases petrol production, improves fuel quality, and makes the process faster and more efficient. So, in simple words, cracking helps us get more and better petrol from heavy oil. If you see in this image, this is a heavy oil equipment, this is a catalyst equipment. The heavy oil is coming from here and the catalyst is coming from here. Both are coming together and reaction is happening here. After that, we will get a pure petrol. Now let's move the next step. Treatment and purification. After the cracking process, the fuel we get is not completely clean. It still contains impurities like sulfur, nitrogen, and metals. These impurities can cause serious problems: air pollution, engine damage, corrosion in pipelines. So, purification is very important. The main process used here is called desulfurification. Now, let's see how it works. First, the fuel is mixed with hydrogen gas. Then, it is heated to around 300 to 400 degrees Celsius under high pressure. After that, it passes over a catalyst. In this reaction, sulfur present in the fuel react with hydrogen and forms hydrogen sulfide gas, also called H2S. This H2S gas is easily removed from the system. Finally, we get clean fuel with very low sulfur content. See this animation. Here, in this equipment, fuel is mixed with hydrogen gas. Then it is heated around 300 to 400 degrees Celsius under high pressure. After that, it is passed through the catalyst. In this reaction, sulfur present in the fuel reacts with hydrogen and forms hydrogen sulfide. This hydrogen sulfide is easily removed from this system. So finally, we get the purified petrol here. Now let's look at the final step in petrol production, the blending process. Blending means mixing different type of fuels along with small amount of special chemicals to make perfect petrol. These chemicals are called additives. Even though they are added in very small quantities, they play a very important role. First, we have octane improvers. This increases the octane number of petrol, which improves engine performance. For example, ethanol and MTBE. Detergents. These help keep the engine clean by preventing deposits. Antioxidants. They prevent the fuel from degrading over time. Corrosion inhibitors. They protect fuel tanks and pipelines from rust and damage. Anti-knock agents help reduce engine knocking. And oxygenates helps the fuel burn more cleanly, which reduce pollution. After blending, we get petrol with the correct octane rating like 91 or 95. Let's see this animation. Here, octane improvers, detergents, antioxidants, corrosion inhibitors, anti-knock agents, oxygenates are added into the petrol. The final result is we get petrol with the correct octane rating like 91 or 95, better engine performance, lower emissions, and fuel that meets government standard like BS6 in India. So in simple words, blending makes petrol more efficient, cleaner, and engine friendly. Now let's look at the final stage, storage and distribution. After all the refining process like distillation, cracking, treating, and blending, the final products like petrol, diesel, and LPG are ready. These fuels are stored in large storage tanks. As you can see the image, separate tanks are used for different products like petrol and LPG. These tanks are specially designed to prevent leakage, avoid contamination, ensure safety. After storage, the fuels are distributed to different places. Distribution is done through pipelines, tanker lorries, ships. From here, the fuel is transported to petrol bunks, industries, and consumers. So, this is a final step where refined fuel reaches us for daily use. Thank you for watching this video. I hope you understand how crude oil is converted into petrol step by step. If you found this video useful, please like, share, and subscribe. See you in the next video. Bye bye.